Hello, everyone. Thank you very much for joining us after lunch. I know it's not that easy to let go of the fish and chips and all the good stuff, but it's for a good cause. I'd like to start with a question just to wake up the audience. And the question is, how does an average company, how many tools does a company use to collect telemetry data from its systems? 25. Any other guesses? Think, logs, metrics, traces. Any idea? Yes, Dan. Just one. So, according to a recent survey, the average company uses between 5 to 10 different tools to collect telemetry data from its systems. 5 to 10 different tools. You can reduce it, as Dan said, to one unified standard platform. Here's the story of Opentelemetry. My name is Dotan Horovits. I'm a developer advocate at logs.io. At logs.io, we provide cloud-native observability platform that's based on popular open source tools such as Prometheus, Jaeger, Elasticsearch, OpenSearch, Opentelemetry, and others. You can find us out there in the booth. I won't speak too much about that, but we are hiring. So if anyone's looking, do pay us a visit at the booth. I'm an advocate of open source and communities in general, also the DevOpsDays community, and also the CNCF, the Cloud Native Computing Foundation. That's where Opentelemetry is. I co-organize the local CNCF chapter here in Tel Aviv, so I invite all of you to join one of our monthly meetups. I also run a podcast called Open Observability Talks, and actually, we've just been on the finalists for Best DevOps-related podcast of 2021. Yay! So thank you very much, and do check it out. And of course, vote us up. It's for public voting now, so go vote us up. And with that, let's talk about observability, as Dan also started off very, very well. So observability, as we already heard, is the ability to understand the state of our system based on the telemetry data that it emits. And the vision talks about unified observability across different signal types, typically metrics, traces, logs, and across different sources, which is also very important. Think about your front-end app, I don't know, Node.js or Python or whatever, and then the backend code, and then there's all sorts of infrastructure, I don't know, Kubernetes, Docker, Kafka, Redis, Mongo, whatever you have there, cloud services. Essentially, fusing all of these signals together to gain unified observability. That's the vision. The reality, however, is much more fragmented. And that's precisely because we use so many tools for our observability. And each tool and each vendor has its own proprietary API and SDK for instrumenting our application so that our source code actually generates and emits logs, metrics, traces, and so on. And then proprietary daemons and agents and collectors to collect that telemetry data and run all sorts of aggregations and sampling and other processing. And then proprietary protocol and the data model for transmitting that to the backend for analysis. And all of that is not only an operational headache and a vendor lock-in issue, it also creates tight coupling between the telemetry collection and the telemetry storage and analysis backends. And most importantly, it makes it very, very difficult to correlate between these different tools and data signals to gain that unified observability across the different data silos, essentially, to get that unified observability we talked about. That's exactly the problem that Opentelemetry comes to solve. So Opentelemetry, or OTEL as it's nicknamed, is an open source observability framework for generating and collecting, capturing data from systems across traces, metrics, and logs. What does it mean? Again, it's a standard way to get our applications to emit logs, metrics, traces, a standard way to collect that telemetry from our applications, from infrastructure components and so on, and the standard way of exporting it to any backend you choose. You want to analyze it with Prometheus, go ahead. You want to analyze it with Jaeger, with Datalog, AppDynamics, whichever, Logs.io. Opentelemetry has no stake in the backend. It supports everything. And as I said, it's an open source. It's an incubating project under the CNCF, the Cloud Native Computing Foundation. In fact, it's a merge of open tracing and open census projects under the CNCF, if you're familiar with these projects. And I'm very glad to say that virtually all the major players in the industry have aligned with Opentelemetry project. All the major cloud providers, all the major monitoring tools, observability tools, vendors, everyone is aligning with Opentelemetry. It's also amazing to see that it's a highly active project. We all like dashboards. We are in DevOpsDays after all. So here's your daily dashboard. That's from the CNCF DevStats. I don't know if you can see at the bottom, but what most importantly is actually here. You can see here, Opentelemetry today is the second most active project in the CNCF. Second only to Kubernetes itself. And that's impressive. So I hope that I convinced you that Opentelemetry is interesting and that you'd like to hear some more. And with that, I'd like to dive deeper into what Opentelemetry exactly is and what it gives us. So Opentelemetry gives us a unified set of vendor-agnostic APIs, SDKs, and tools for generating telemetry, logs, metrics, traces from our application. This is the bluish part that you can see here on the left-hand side. And then a standard way for collecting that telemetry, that's the green part, a standard way of transmitting it and exporting it, and sending it to whichever backend you choose. That's Opentelemetry in a nutshell, and I'm going to dive deeper into each and every one of the main components, don't worry. But first, I would like to say a word about Opentelemetry specification. Let's see if my clicker, okay. So Opentelemetry specification is not a component, but rather governs all the other components and provides the cross-language set of requirements and expectations from all of Opentelemetry's implementations. So it defines the API spec, it defines the SDK spec, it defines the data spec, things such as semantic conventions and so on, across metrics, traces, and logs. And that exactly comes to solve the exact problem we talked about before of fragmentation, that each vendor and each tool has its own convention and its own format. So that's a specification. And the first component you're most likely to encounter when you start your journey with Opentelemetry is the client libraries. Opentelemetry provides you with one API and one SDK per language for instrumenting your code base. So if you have Java, you have the Java SDK. If you have .NET, you have the .NET, and so on. It also provides integration with all sorts of common libraries for your language, RPC libraries, storage libraries, and so on, web frameworks, to extract telemetry off of these libraries as well, and also auto-instrumentation agents to automatically extract from certain languages so that you can do it with even less coding. So essentially, Opentelemetry offers the full range from fully manual instrumentation all the way to automatic instrumentation of your code base and anything in between. That's the first piece. The second piece is the Opentelemetry collector. And the collector is a standard way to gather the telemetry, process it, and send it to your backend of choice. And it's built, as you may imagine, as a typical data pipeline. So you have different receivers to receive in multiple protocols. Then you have a different set of processors to run all sorts of activities, and then a set of exporters in different protocols. So you have receivers, for example, if your application emits tracing data in Jaeger format, you just plug in the Jaeger receiver. If if your application emits metrics in Prometheus format, you plug in the Prometheus receiver. If you have things from AWS or Azure or CollectD or any other thing, just plug in the right receiver there. Then you have a set of processes that perform all sorts of activities such as filter, a batch, sample, and so on. And of course, you can chain different processes to get more elaborate processing logic. And then you have a rich suite of exporters through which you can send to your backend of choice. So you want to analyze it with Prometheus, you have the Prometheus remote write exporter. You want to send it to AWS X-Ray, you plug in a AWS X-Ray exporter. You want to analyze it with Logs.io, Logs.io exporter, and so on. It's really up to you and very pluggable. So that's the collector piece. And the last component I'd like to talk about is the Opentelemetry protocol, or OTLP. And that's a standard and unified protocol for transmitting telemetry data. It can be used to communicate between the SDK and the collector. It can be used to communicate between the collector and your backend tool of choice. It can again be used between different intermediate nodes, such as different collectors and so on. It's really agnostic to the specifics. And it defines, it's a client-server protocol, request-response, and it's based on, I don't know if you can see on the lower line here, so I'll read. It's based on the gRPC and HTTP 1.1 transport. It uses binary protobuf encoding, which means that you essentially can take the .proto file and generate your own gRPC client yourself, if you so choose. There is in the works, by the way, to do the same for the payload based on JSON. So this is in the works. And last but not least, it also defines the telemetry data model. Standard way, based on the same specification we talked about before, for how to represent your telemetry data, your fields, and so on. So that's OTLP. And it's important for me to emphasize, Opentelemetry does not mandate you to use OTLP. We saw before, the collector can work with many protocols for receiving and for exporting. So it's up to you. However, as a holistic framework, Opentelemetry aims to also provide a unified protocol to converge the industry also on the way of representing and transmitting telemetry. And that's also the case also for other components. You can use the collector without using SDK, OTel SDK. You can use SDKs without the collector and so on. So it's loosely coupled in general, but yet a holistic framework aiming to provide end-to-end way, standard unified way to generate and to collect telemetry data from systems. So these are the main components of Opentelemetry. There are more, but these are the main ones that I can cover on this talk. And now the question that I'm often being asked, so what's the state of Opentelemetry? And most importantly, is that GA? Can I use it in production? And any guesses here? Yes, no? Who thinks yes? Raise your hands. Okay. Who thinks no? Raise your hands. Okay. And who thinks it depends? So you're right. Like any interesting system and any interesting question, it depends. And the reason it depends is because Opentelemetry is an aggregate of multiple groups and multiple projects, sub-projects, each dealing with a different piece of this enormous endeavor. So you have a group working on the tracing specification, and another on the metric specification, another on the logging specification. There's a group focused on the Java SDK, and another on the Python, and so on and so forth. And each group and each such sub-project has its own life cycle, which means the different components of Opentelemetry may be in different stages of their maturity life cycle. And the maturity life cycle goes from draft to experimental, to stable, to deprecated, just to align the terms in Opentelemetry, where stable is roughly what you'd say GA, generally available, what you'd be looking for to run it in production, in your systems. Experimental is a good place to start POCing the technology. So that's just to align the terms. And still, okay, we understand it's complex, but what is the state of Opentelemetry? And I'd like to answer that question, break it down based on the different signals. And the first signal, and the most mature one, is traces, and Opentelemetry is stable for traces. So GA, meaning that the API and SDK and protocol specifications are stable. The collector piece, the tracing piece of the collector is stable. We have quite a bit, I don't know if you can see down here, so I'll say many client libraries are already version 1.0 or above. 1.0 is when it reaches completeness of the tracing implementation. So Java SDK is there, and Go, .NET, Python, C++, JavaScript just joined last month. And more languages joining, Ruby, PHP, and others. And most importantly, stable means you get guarantees for long-term support and backwards compatibility and dependency isolation and so on. So that's traces. And next up is metrics. That's expecting stability by the end of this year. So expecting good news in the coming month. With the protocol and API already stable, the SDK very soon to be stable. It's already in feature freeze. The API and SDK specifications are already prototyped in Java and .NET and Python. And there's a lot of work in the collector. It's still experimental, with lots of work in collaboration with the Prometheus group under the CNCF to get the Prometheus support within Opentelemetry. And last on this is logs. That's farther behind. The protocol and the collector for logs are still experimental. The API and SDKs are still in draft mode. And the focus generally for logging is first to get the integration with existing logging systems. So be able to fetch the logs, transmitting them uniformly over OTLP. Lots of work also on log appenders in many languages to append, for example, trace data on top of logs, adding trace ID and things like that. I'm glad to say that my peers at Logs.io are working diligently on some of these pieces. So that's where logs are. And now let's talk about how to get started with Opentelemetry. And here I'd like to offer my bit of advice, and that starts with knowing your stack. So answer 4 basic questions about your own stack. First, which programming languages are you using, especially if you're a polyglot organization? What's the front end? What's the back end? Which languages are going to emit? Maybe also in which frameworks and libraries that you use. And that will determine the SDKs that you're going to use, and maybe auto-instrumentation agents and so forth. Next up, which signals, logs, metrics, traces, and also in which protocols, which is especially important if you are a brownfield project. So if you already have components there emitting and you need to conform to that format. And that will determine, of course, the receivers that you will need to use, and then which analytics backend that you're going to use, that will determine the exporters that you will need to use. Based on that, once you understand the framework, then you can go check the state of these different components and then follow the guides. And there's a useful page, opentelemetry.io/status, to go and visit. I'd also like to invite all of you to check out the guide to Opentelemetry that I wrote. It's actually quite popular, so if you Google Opentelemetry guide, Opentelemetry tutorial, something like that, it will probably be the #1 result. And it provides a comprehensive guide to the different components we talked about, to the different protocols, the state of the different projects. It also has sub-guides to the different languages, so a sub-guide for Java, a sub-guide for .NET, a sub-guide for Python, and so on. And useful links to drill down to your specific path of investigation. So do check it out. You can take a screenshot of that before I move on the slide. And feel free to provide also feedback. And I'd like to finish with a final note to encourage you not just to provide feedback on my guide there, but in general, that's an open source project. It's all of our project, and we can all make it better together. So whatever you think that you can contribute, whether commenting on issues, opening your own issue, opening issues, or even PRs and contributing code, anything that you can do to make sure that this indeed becomes the de facto standard and the unified framework for all of us to collect telemetry and generate telemetry, that'd be great. If you have any feedback about the guide, about the talk, about anything else, feel free to reach out to me at Horovits. Again, you can't see that at the bottom. I'm here at the conference or over Twitter, over GitHub or any other way. I'm Dotan Horovits, and thank you very much for listening.